Hi, my name is Gerri Bernard. I'm a senior physics teacher. I'm the head of curriculum development for science, and I'm the unofficial director of the Dorothy Hill Observatory at Brisbane Girls Grammar School. And today I'd like to talk to you about how we found space for observational astronomy in our science curriculum. So a little bit about our school. We're a private secondary school for girls located in Brisbane, Australia. We teach years 7 to 12, and we've got about 1,500 students. We're really proud of our science program at our school. More than 90% of our students elect to take a senior science, and about 40% of our girls take physics as a senior science. In my role as the unofficial director of the Dorothy Hill Observatory, I'm in charge of integrating this fabulous resource into our science curriculum. You can see that our observatory is fully remote and robotic. It's located about 2 hours north of our main school campus to get it far away from the bright lights of Brisbane. The observatory is mainly accessed by the students via their laptops from the science classrooms on our main campus. They do come up to this site and they do visit, but most of the use is going to happen in the classroom for the students. Let's take a look at what we've got inside. We've got an 8-inch celestron. This is the telescope that the girls will use when they're actually at the observatory. It doesn't have a camera. We've got an 11-inch celestron. We have a 4-inch Takahashi that's mainly used by our year 7 students. And then we've got our workhorse, our 14-inch reflector. And that's got a really nice camera on it, and it's got a 10-position filter wheel. So we can swap those filters in and out depending on what sort of project we want the girls to do. So our setup is that the students only have remote access and that all of their requests are facilitated by myself and our support staff. So Anthony Lumsden, who's our observatory manager, and Dr. David Trappett, who built the observatory for us. Very lucky. And what happens is that the students will make an image request using their laptop, and that image request will get kind of filtered through the staff to make sure that it's correct and accurate, uploaded to our scheduler at the observatory. And then over the course of time, the images will get taken. Once the images are taken, those images will move back to the school server where the girls can download the images from their laptop sitting in their science classroom. So who uses our observatory? All of our students in year 7 to 9 use the Dorothy Hill Observatory, and we facilitate this using what we call observatory modules. So each module takes about 2 to 3 lessons and is delivered by our regular science classroom teachers, and the girls will sit approximately 3 modules a year. The modules get more complex as the year levels go on, and the focus is on astrophotography. And so this results in more than 700 image requests to our observatory every year, and about 400 images generated by our students every year. Let's take a look at these modules in more depth. So each module has a conceptual component where the girls will learn what they need to know in order to understand what they're doing with these telescopes, as well as a practical component where the girls will either request an image from the observatory or process an image that's been taken by the observatory. More modules in years 8 and 9. So in year 7, the girls will be using the 4-inch refractor telescope. In years 8 and 9, the girls will use the 14-inch reflector, and year 9 specifically focuses on narrowband imaging. So how do we fit this into an already jam-packed science curriculum? You can see our general schedule for year 7 down at the bottom there. So we start in January and go to December, and we've got 4 terms. And you can see that no term actually focuses on astronomy, unfortunately, in year 7. So the way that we fit this in is we use that little bit of extra time at the end of each term after the girls have sat their exam, but before they go on break, to sneak these modules in. So for example, module 1 will run at the end of term 2, and then module 2 will run at that little bit of space at the end of term 3, and then module 3 runs at the very end of term 4. So let's take a look at module 1 to see how this goes. At the start of module 1, the girls are introduced to the Dorothy Hill Observatory. They're shown a live view inside the observatory to see how the telescopes move to track objects across the sky. Then they move into their conceptual component where they learn some basic astronomy, especially distances, so that they can understand how far away these beautiful objects are. They learn about nebulas, star clusters, and galaxies, which are the types of images that they can request pictures of in Module 1. They then move on to the practical component, where they use our in-house developed resources to follow the steps to choose a nebula, star cluster, or galaxy to get pictures of. And then they're taught how to send that request to the observatory. So the girls have requested their images, they go on term break, they come back, they start learning the next term's physics. And in the background, the telescope is taking all of their hundreds of pictures to fulfill all of those requests. And it does take a good couple of months, but that's okay because they're busy learning their physics. So when their physics is done and the telescope has taken all of those pictures, they do Module 2, again, 2 to 3 lessons. In the first lesson, they'll learn about astrophotography, they'll learn about pixels, how telescopes work, how CCD cameras work, so that they can understand this image manipulation they're about to do. And then again, they go through the steps in our in-house developed resources to download their images, stack their images, and load that final stacked image into Photoshop to process it, to bring out the natural beauty of the object that they've chosen. So in year 7, of course, this can result in some very interesting astrophotography. We can get some purple galaxies and some orange nebulas. But as the year goes on and they reprocess their images, they start to build their skills. So they're using our 4-inch Takahashi refractor here, and they can get some fairly good pictures out of them. In year 8, the girls will start to use our 14-inch reflector, and that's where the image quality really bumps up. And so they can image all of these beautiful nebulas and get some pretty good astrophotography going. In year 9, which is my favorite, the focus is on narrowband imaging. And that's when the girls can really take off and produce some beautiful images that also give them that scientific information about where the gases are located in that particular nebula, the oxygen, the hydrogen, the sulfur. We support our curricular program with a co-curricular program. So that's Astronomy Club for the years 7 to 10, where the girls can learn some basic astronomy, they can make their telescopes, and they can start doing small research projects. And then in the senior years, years 11 and 12, the girls can join what we call STARS, which is where they can use the telescope to do full research projects, resulting in publications on topics like double stars, RR Lyra, and exoplanet transits. So thank you very much. If you have any questions at all, please feel free to contact me at the information below.